This is one of my favorite sections, actually. Every section is my favorite section when you're having fun. So, if we are given polar coordinates, we're going to see this with vectors too when the seniors are gone. But you get it here. This right here is the thing, if you go on to physics, you will use the most of any other thing I've ever used in physics. So, in physics, a lot of times we're given a direction and a length, or a direction and a speed, right? So we need to be able to convert that direction and angle into an XY coordinate. This is how you do it. This is going to be true with polar. This is going to be true with vectors. This is going to be true, I think we saw it a long time. It's called it's called stuff. All right. Why are there people in here every day to take pictures? Don't you guys have enough pictures of this classroom? Great video. All right. Why is x r cosine of theta, do you think? What's cosine give me? X. What's sine give me? Y. So, if I'm given polar coordinates, I can convert them to an xy using these two formulas. And I can also go in reverse. If I'm given an x and y, I can convert it to polar. Because think about this. In a polar coordinate, if I have a point here, can't I just use Pythagorean theorem to find where that point is? Pythagorean theorem to find your radius. And then also to find this angle, isn't that always going to be y over x? So you tan inverse y over x will give you the angle. Okay? So this is actually kind of a review of everything we've seen. So let's do it. These are my polar coordinates. Let's convert them to x and y. So x equals r cosine of theta. Remember this is r theta, radius, angle. What's my r? 3 cosine of 5 pi over 6. Right? And, oh man, I get to talk about that tomorrow. I'll be here tomorrow. All right. What's cosine of 5 pi over 6? Nate. Now this one's easy since I'm finding the x coordinate. Which one is it? The x coordinate, right? So it's 3 times negative square root of 3 over 2, which is negative 3 root 3 over 2. That's my x coordinate. Because what I'm doing is, this is actually, do you guys remember similar triangles? A little bit, a scale factor. All these are similar triangles. We're just finding the radius is changing. Instead of being a length of 1, it's a length of 3. It's all similar triangles, actually. All trig is similar triangles. All right, anyway, I digress. That was fun. So y is 3 sine of 5 pi over 6. And what's sine of 5 pi over 6? Isn't it positive 1/2, I believe? So I get 3 halves. So what's my xy coordinate? Negative 3 root 3 over 2, 3 halves. Yeah, you guys want to know something really interesting? Fun fact. So let's say I am running at, Kate and I are running at each other full speed. And I'm running with a force of 5 joules, or 5 newtons, let's do 5 newtons, is my radius, and I'm moving at a specific angle. And then he's moving at a different angle and has a force like 7. When we hit, how do we know where we're going to end up? You do this with both of us, and you just add the 2 points together. Car accidents, how do they know where the car is going to end up or how fast the car is going? They just do that and add them together. It's actually that easy to do physics. Like that's how they did, like forensics. Like a car goes off the road, collides with something, and it bounces off so many feet. You're just doing this. Like you guys at the end of, if you're here for Unit 4, will be able to do the math that like Unit 4 that they do in physics for like collisions and stuff. All right, let's do this one. What's my x going to be? 2 cosine of negative 7 pi over 6. Yar? Negative 7 pi over 6 down my unit circle. Can I figure it out? It would be up here, right? If you don't see that, what else could I do? You could always add 2 pi to it, right? And that's what, 12 pi over 6? It's 5 pi over 6. Wait a second. This was 5 pi over 6. So what's cosine of that? Negative root 3 over 2. And then my y will be 2 sine of negative 7 pi over 6, which is 1/2. So not too bad. This actually is not too bad usually. So my final answer would be negative 2 root 3, 1. What's this called? What's this in form of? It's not polar anymore, it's rectangular. This is a rectangular coordinate. Because what's the coordinate plane look like? A rectangle. Yeah. To do what? Oh, yeah, you definitely could. That's why I make the big bucks, guys. I'm hoping to get discovered by some college on these, and then they'll take me away. The only college professor I ever saw this flagged my videos. Oh, I took too long on that problem. Why? Wild. Oh. No, the screen actually just turned off. It's working over here. What a good video this is. Who, what? No, that's not, I wasn't talking about you. I could have been talking, there's tons of them in the world.
Yeah.
No, I said there's people that came in.
You two were running at each other.
Yeah, and I was running at the people who came in. If some people came in, y'all can't hear. All right, let's do the opposite. Now we're given rectangular coordinates, and I want to find the polar coordinates, and I'm going to show you why it works. So again, if I have the point 1, negative 1, it's right here, right? I need to find two things. I need to find an angle and a length. How would I find that length if this was a triangle? Pythagorean theorem, right? So this is why I tell you guys, memorizing things are good, but just understanding what's going on is even better. You know what I mean? If you can see, like, it's going to be Pythagorean theorem to find my r because it's a right triangle, then r squared equals my x squared plus y squared, right? You know what I'm saying? Also, that's your distance formula, right? You're finding the distance away from 0. So my r is going to be root 2. Now the other question I'd ask is how would I find, how am I going to find this angle right here? If this was a triangle, I have opposite and adjacent, right? So how would you find that angle? You would set up tan of theta equals my y over x, my opposite over adjacent. I should put negative there. And then what do I do both sides to get theta? I tan inverse it, right? Yeah. And what's tan inverse of negative 1? Where are my x and y the same down here? At 7 pi over 4. But now I'm looking for that theta. That's 7 pi over 4. So if I want to go that direction, I guess I could do either, right? Now, I would actually call it, your calculator is going to give you negative pi over 4, but technically, could you put 7 pi over 4? Yeah, both are correct. Because do you remember in the video, there's more than one way you can write every single point. You can go either direction. You'll end up in the same area. It's kind of like if you take a right and then a left, it's the same thing as taking a left and a right. That's not true. That's not true. How about this? If I spin this way and then this way, it'd be, never mind. Just stop. Just stop, Mr. Twilliger. You're an idiot. All right, let's do this one. 2, 0 would be right here, right? Oh, no. Yeah, 2, 0. I don't know why I drew a circle. Oh. All right, so what's my R going to be? Watch this. How long is this line? 2. Do you want me to prove it with Pythagorean theorem? I'll do it. R squared equals 2 squared plus 0 squared. R squared equals 4. What's R? 2. But you see what I'm doing? Remember, these are physical things. Memorizing formulas isn't as helpful as just knowing what's happening. Because remember, if it's on the line, I can just count how long it is. It's 2. What's this angle right here? Do I have how do I know that angle is 0? Just go straight. It's at the starting point. Now, remember, this one I can't draw a triangle. If I had this one, could I draw a triangle? No, but that's pi over 2. This one, can I draw a triangle? No, but it's a straight line. It's 1/8. It's pi. You know what I mean? So the quadrant ones, you don't draw it out. Let's see if the formula works. I could have done the formula because I could have done tan inverse of 0 over 2. Tan inverse of 0 is 0. Because where's tan 0? At 0. It's also 0 at pi, correct? But that's not in the right zone that we're looking at. No, because that would be negative 2, 0. You have to know what quadrant you're in. Yeah. Neither. You're in the border, but you have to know where you're at. How about that? You know where you're at. That's a good question. All right. Let's take a look at example 5 and 6. Let's take a look at example 5 and 6. These are going to be amazing. So, here's something we need to recognize. I just kind of talked about this. I alluded to it. If we are in quadrant 1 or 4, tan inverse of y over x gives us theta, right? Because where does tan inverse gives us the value of tan on the right side of the unit circle. So if we're in 1 or 4, it works, and we're done. If we're on the other side, tan inverse doesn't work, right? Because tan inverse only hangs on that side. So what do I do if I'm hanging out on the left side? I have to add pi to my answer. Okay? If I'm in quadrant 2 or 3, and again, that's because that domain is restricted to the right side. So if I want the left side, I got to add pi. If I want the left side, I got to add pi. Left side, add. Good. We're good. That's all we need to know. Absolutely, maybe. It probably should be. All right. Now, what if we need to change an equation to polar? So that's not a point, that's an equation. What do I do? What does y equal? in polar? R sine of theta. So I'm going to plug in R sine of theta for y. What does x equal in polar? R cosine of theta. And that's going to be squared. It's going to be a half. So far, I've just done basic substitution, right? Is this an equation? There's more than one variable, right? Can I plug this in a calculator? So I need to get rid of a variable. So how am I going to do it? Oh, I'm sorry, I said that wrong. So usually we do y equals like 3x plus, 2. That's a thing. For polar, our goal is to get r equals something theta. Okay? Do you guys have your graphing calculators on you? I'll prove something to you guys. No, absolutely not. I am a calculator. A bad, broken calculator with missing buttons. No. You're thinking of logs when we do logs. Hit your mode button on your calculator. Change it to polar. Do you guys see where it says func? Yeah, change it to polar. Do you guys see where it says func? Change it to polar and hit enter, and then hit your y equals button. What's it say now in your equation? So you want to get r by itself for polar. Okay? In rectangular, we get y by itself to graph it. In polar, we're going to get r by itself. Are you sure? All right. So how am I going to get r by itself? Let's do some work. Does this squared hit both these? Yeah, so it's going to be 1/2 r squared times cosine squared of theta. Now, what I'm going to do is I'm going to multiply this side by 2. Do you guys mind if I do something cray-cray? Can I multiply it by 2 over cosine squared? Because I want to get rid of that cosine squared. I want to get rid of that 2. Is that kind of... So that will cancel. And that will cancel. So I'll just be left with r squared. So I'll multiply this by 2 over cosine theta squared. So this side will become 2r sine over cosine squared theta equals r squared. How do I get rid of that r? Divide. Ooh, this worked out well. If I divide both sides by r, what's this become? R. Technically, you're done there. They took it another step because what you could do is I'm going to show this to you, so don't freak out. It'll be in the... This is right. Kinda. No, this is right. Could I also call this 2 tangent of theta secant of theta?
Yes.
Because what's sine over one of my cosines? Tangent. And then what's 1 over my other cosine? Secant. So beware, these are the same thing, right? Because I could prove that's that. You guys kind of see what I'm talking about there? I can prove that.
So you're using one of your sides, treating another cosine.
Yep. Because I'm bringing that into cosine times cosine. Sine over cosine's tangent. 1 over cosine is secant. All right, let's do this. Should we do that, beast? No. I'm not going to do B. Because I have a gut feeling that you won't see one like that one on test. Yeah. I've never seen one like that one on any of the tests I've taken. The other one's possible. All right. What's x equals 4 look like as a graph? It's a vertical line right here, right? So what's r equals 4 mean in polar? It means your distance is always 4. So what shape does that make? If you don't believe me, in your calculator, if you put r equals 4 and hit graph, you're going to see a circle. Yeah. If you play, because remember, it's just saying, because it doesn't matter what theta is. Is there anywhere to plug in a theta in this? I'll show you. You have to change windows to get it. There's some, but your radius is always 4, and your theta is everything. It's kind of like this is your y is everything, and x is only 4. So now, can I write this as a rectangular form? This, I hope you guys did this in algebra too.
I don't.
What's the equation for a circle? That's your equation for a circle. X squared plus y squared equals r squared. Wait, where have we seen that before? I told you, the more you learn about math, it's all together. It's all the same stuff. That's the equation for a circle. What's my radius? 4. So what's 4 squared? There you go. That's your equation. That's it. Now let's say I didn't know the equation for a circle. What's my equation for r in polar coordinates? Do I have a theta? Nope. So what would I do? I'd plug in my 4, and what do I get? Is this all in terms of x and y? You're done. This is your answer, yeah. Either way you do it, because they're the same thing. Now what you do with this, though, what's this going to look like? This is theoretical stuff. If I'm drawing polar, theta is 2 pi over 3, right? Where's 2 pi over 3? Right here. Now what's my radius? All the radiuses. So that makes a straight line. But it doesn't go down below because it's not negative, right? So if you're just given theta, it gives you a straight line. Now you guys want to know something real wild? How do I find the slope of this line? You guys want to do it the rise over runway? That's what I would do. Do I have an x and y coordinate? So I would do, oh no. That was a bucket, just so that. I would do what? Root 3 over 2 over negative 1/2, correct? That's my x and my y at that point. So when I multiply by my reciprocal, what happens to this? It becomes negative root 3 is my slope, right? So does it pass through the point 0, 0? What's my y-intercept in y equals mx plus b? 0. So my equation is y equals negative root 3 times x. Now, never mind. Again, I don't see a lot of problems like this, but it's interesting though. I am not. I'll do C and D when we get back. I'm not going to do 7 though. But I will cut a bunch out. What did I give you guys? You do not have to do problem set 1 all. Save this on the video. It's good. so you guys can watch back. If I were you guys on problem set 1, you should be able to do 1 through 20. 1 through 20. 1 through 20. It doesn't take as long as you think it's going to. Oh, stop the video. Let's not publish this one.